Right. Okay, I'll see this. Okay, all right. So the diagram shows an electric current used to determine the brightness of the light in a room. So add a voltmeter to the diagram to measure the voltage of resistor R. So we know that how the voltmeter is connected. It is always connected in parallel across that component, right? Uh, State the formula linking voltage, current, and resistance. We all know V equals to IR. The voltage across resistor R is 1.9 volt. The resistance of resistor R is 800 ohm. Calculate the current in the circuit. So voltage across resistor R is 1.9 volt, right? And the resistance is 800. So V over R, where V is 1.9 and resistance is 800. Yes, can you please tell me the answer, Marine?
It's 2.35375 times 10 to the power of minus 3.
Minus 3. So that means it's about 2.35 milliampere, right?
It's 2.375.
Oh, sorry, 375. All right. Explain why the voltage across the, uh, why have I taken only 2.37 and I have not written 10 to the power minus 3 here? Yes, because this thing means milli, okay? So it is already written here, right?
Yeah.
Now, explain why the voltage across the light dependent resistor decreases if the brightness of the light in the room increases. वकार भाई, या आप रुक जाएं, मैं देख लेता हूँ। चलिए ठीक है, सही। All right. Okay. So explain why the voltage across the light dependent resistor decreases if the brightness of the light in the room increases. So why voltage across the light dependent resistor? LDR is connected in the circuit. You can see here the LDR is connected in a series with the resistor R. So the question says that why voltage across LDR? Why voltage across LDR decreases if the brightness of the light in the room increases. Yes. Don't you think that this circuit is automatically be controlled? Yes. The circuit is being controlled with the brightness in the room. Yes. If the brightness is going to be increased, so that LDR uh, is going to uh, allow less voltages. That means the resistance of the LDR is going to decrease. What do you think? Yes, hello.
Yeah.
Because voltage, when the voltage decreases, when the resistance decreases, the voltage also decreases, right? Okay. So this is how we are going to write as the resistance of LDR decreases with the increase in the brightness. Okay. And how do I know this? Because voltage is discussed, voltage across LDR decreases. Okay. So as resistance, resistance of LDR decreases, the 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 voltage drop across the LDR will also decrease due to increase in the brightness of the uh, light in the room, right? So what will happen the resistance if the resistance decreases? So what will happen to the current?
More current passes through when there's less resistance.
Yeah. The so the la so the current would increase, right, as resistance decreases. So there's no need to mention this point again and again as resistance decreases, right? Okay. So now the voltage supply is constant, right? Here's a constant voltage supply, right? Here's a constant voltage supply. So if the voltage across the LDR decreases, so the voltage across the resistor increases, right? Clear? So that we can have the same voltages dropped across the entire circuit, right? For example, if I have 12 volts here and initially I had 7 volts and then I had 5 volt. Now when the voltage gets decreased, let's say it comes to 4 volt, so it has to increase itself to make it 12. Okay. Yeah. So this is how it is going to happen in the circuit, in a series circuit. If one voltage, decreases, the other voltage has to be increased to make the sum constant, right? So we can also include this point. The voltage across resistor R voltage across the resistor R increases. Uh, so to keep the to keep what? To keep the total voltage remains constant, right? Keep the total voltage constant. See, this is the 4-mark question. We have to include all the points, right? Okay. And even we can also include over here that LDR and resistor are connected in series. Therefore, total voltage splits. Yeah, right? Now, another resistor is connected in parallel with resistor R. The new resistor has a higher resistance than resistor R. Okay, so the question says that another resistor is connected across this resistor R, right? And this time, this resistor uh, has greater resistance than R, right? So explain what happens to the current in the LDR and the circuit diagram. Explain what happens to the circuit. Sorry, what happens to the current in the LDR and the circuit diagram. What happens to the current in the LDR and the circuit diagram. So if you add number of resistors in parallel, you remember what happens to the effective resistance. Yes, type if you want to add on, or Marine, you want to add on.
Uh,
If I if
uh,
I keep adding number of resistors in parallel, what happens to the effective resistance?
it, it decreases since there's more paths for the current to flow.
Yeah, it decreases, right? Marine, what do you think? If I keep adding number of resistors in parallel, so what happens? What happens to the current in LDR? Will there be
It
any
would
effect?
decrease because it keeps getting divided.
Yeah, so because more resistance is added in parallel means that effective resistance would decrease, right? So the more current will flow through the LDR, right? And what will happen to the, oh, yeah, assume that the brightness of the light in the room remains constant. And what will happen to the resistance of LDR then? Will the resistance of LDR be constant? Because the room brightness is not changing. Yeah. So what we have discussed that resistance in parallel combination, the effective resistance would decrease, right? Yeah. The effective or combined resistance would decrease in parallel combination. Okay, right? So what happens? The more current flows through the LDR, right? Okay. All right. Now this question is about measure the mass of the clay piece of liquid that could pot and determine the volume of liquid that will be. Okay, this is related to density. Would you guys do this or okay, let's do this one as well. The diagram shows a pot made of clay. क्या हुआ? What happened? The diagram shows a pot made up of clay Describe a method that could be used to accurately determine the volume of clay used in the pot. Describe a method that could be used to accurately determine the volume of clay used in the pot. Okay. Volume of clay. How can we find out volume of clay used? And we do not know uh, the value of density and other things. Yeah, water displacement method. Thank you, Thai. Uh, Displacement method is used to measure the volume, right? So use a user displacement method. And how will you describe that displacement method? Yes. What we will do, we will fill the pot, okay, with the water, and then fill the pot with the water, then or fill the pot with water, uh, measure amount of water. Yes, Marine, what do I have to use to measure the amount of water? Measure the amount of water used. Measure the amount of water used by measuring cylinder. Yes, by measuring cylinder. First of all, what you have to do, you have to take a amount of water in the measuring cylinder. Okay. And then you have to add that amount in the pot. Okay. So you will come to know that how much volume of water is taking space inside this pot. Okay. Right. So what are we going to do? Uh, we will measure the amount of water and repeat the experiment to avoid which errors? To avoid anomalous, right? To avoid anomalous reading or measurement. Okay, right? And make sure there should be no splashing of water. Okay. Uh, Avoid splashing of water, right? And mm, what we can do, yeah, type. Sorry, I got your point. You just mentioned that the question is asking about the volume of the clay used in the pot. Oh, yeah, yeah. I got your point. Okay, just a second. I want to remove this. The question is asking about the volume of the clay used in the pot. So what we can do, we are going to follow the same step, but we have to mention in a different way, right? Uh, we will take the volume, okay, in the container uh like a container which is known as Eureka can, right? Have you seen the Eureka can ever? It's a can where you can fill the water, fill the liquid, right? And and then you will measure the amount of the volume using the measuring cylinder when it is splashing, right? When you pour something. So what I'm going to do, I'll take the Eureka can, okay? It looks like this. So I will fill the Eureka can with the water, okay? So fill the Eureka can using water, okay? Right? Then place a uh no, pot inside the Eureka can such that the water displaces through this spot. Okay, the water will definitely start coming out from this outlet. Okay, when this pot is allowed to immerse in this Eureka can, right? Okay, and when the water starts coming out, you will collect the water in the measuring cylinder. Okay, and then you will measure the amount of the volume that is collected in the measuring cylinder, right? Collect the water coming out from this part, right? In the measuring cylinder, right? In the measuring cylinder, and then set line of sight to avoid parallax error. Okay. Repeat the experiment to avoid anomalous reading. Okay. Is there any confusion in this answer? Marine, could you please tell me if the points are clear to you? Type, thank you very much to rectify me that they are asking about the volume of the clay. Yes, hello.
Yeah, it's
If there
clear.
is okay, thank you. So this method is known as, again, this method is known as displacement method. Okay. Type, is this clear? Thank you. Give the name of a piece of apparatus that could be used to measure the mass of the clay pot. So you can use balance, or you can also write electronic balance, right? Now the next part of this question says that the clay pot can be used to hold liquids. A student needs to determine the volume of a liquid. Uh, a student needs to determine the volume of a liquid that can be contained in the uh, pot. Okay, the student measures the mass of the empty pot and then measures the mass of the pot again when it is filled with a liquid. The table shows the student's measurement. Mass of empty pot in kilogram is 1.2. Mass of the pot filled with liquid in kilogram is 6.8. The density of the liquid is this, that is, used inside the pot, and calculate the volume of the liquid that can be contained in the pot. So, oh, this question is of 4 mark. Yeah. So, what should we do? Are we going to, first of all, are we going to find out? See, they are asking about volume of liquid, right? So, we have the density of the liquid, okay, and we have the we do not have the mass of the liquid, right? Mass of the pot filled with liquid, okay? Mass of pot filled with liquid. So can we subtract the 6.8 and 1.2 empty mass so that we can have the mass of liquid? Yes. What what will be the answer? It's going to be 5.6. 5.6 both are in kilogram, therefore we are getting in kilogram, right? Now we got the mass of liquid, we have the density of liquid. We can make subject volume. So volume equals to mass over density. Mass is going to be 5.6 and divided by density of the liquid, which is 920, right? So what answer are we getting here? Yeah. Hello. What are we getting? Oh,
It's 6.086 times 10 to the power of minus 3.
-3. So have you fixed the calculator? Have you fixed the calculator in scientific notation? Or I think engineering notation. Can you please tell me the values in decimals? It's going to be around 0.06, I think. Or, okay, oh, yes. Yeah, 0.00 609. So we can write it 0.0061. Thank you, Thai. Thank you, Marine, as well. All right, so it's done. Oh, wow. Again, we have got the questions of velocity time graph. All right. The photograph shows a car being driven along a straight race track. The car starts from rest and accelerates along the straight race track. After crossing the finish line, the driver applies the brakes to bring the car to rest. And the graph shows how the velocity of the car changes with the time. Okay, so its velocity is increasing, but its acceleration is decreasing, right? Yeah. Do you all agree with this? Velocity is increasing, yeah? This velocity is increasing. See, every time we are getting a increase in the velocity. But if you find out the change in the velocity, so change is decreasing, right? That means acceleration is decreasing. This is clear. Acceleration is decreasing here. So what feature of the graph gives the magnitude of acceleration of the car? area between the line and time axis, level curved section of the gradient of the line. Yes, yes, quickly. Yeah, come on. It should be gradient, right?
Yeah, gradient.
Gradient of the line, okay? The gradient of the velocity time graph gives the acceleration, okay? At which point on the graph does the driver of the car first apply the brakes? Yeah. Does the driver of the car first apply the brakes? Yeah. It was moving, if it is moving with a constant speed, okay, you will put a ruler, okay. When it is straight, the brakes are not applied. When the brakes are applied, there will be the change. So at what point the driver has applied the brake? Yes. Oh, wow. They have given these points, P, Q, R, and S, right? So when he applies the brakes, so the velocity is going to be, changed, and then it comes to the the value lesser than the previous value. So the final speed is going to be less than the initial speed, okay, when the brakes are applied. So it's going to be Q, right? Is it going to be Q, right?
Yeah.
Okay. Explain why the graph is curved for the first 11 seconds. First 11 seconds, the graph was curved. This is curved. Okay. For 11 seconds. Yeah. Because if you constantly increase your speed, so the air resistance would also increase. The drag or air resistance increases. Yes. Yeah. So when the speed increases, drag or you call air resistance increases, right? Clear? And then what will happen to the resultant force? Resultant force decreases, okay? And then there's a point comes where the terminal velocity is achieved, okay? Therefore, acceleration decreases and